Hi everyone, thank you so much for joining. This presentation is very much based on my own experience and trajectory as a data scientist, but hopefully through sharing my journey with you, you might gain some insight into the role and its requirements. So about me. So before becoming a data scientist, I was actually a neuroscientist working in universities, trying to understand what motivates our behavior. Is it signals within our environment, or are our actions actually born out of our desires? So I was studying very small parts of the brain that regulate behavior. And through working as a neuroscientist, I obviously had a lot of experience just looking at data, forming hypotheses, creating experiments, working with statistics and visualizations, and dealing with what we will call time series data, so data that's moving through time, and large amounts of data, and data of different types as well, so images and numerical data. So why I thought I could potentially move into data science was that I really loved the potential of using a mathematical model to predict sequences of behavior based on previous data. So using behavioral experiments to then predict what a next action might be. And I had some experience of doing that with recurrent neural networks. But more generally, I love problem solving. I like creating hypotheses and experiments to test these hypotheses. I also love looking at data. So I like data visualizations and understanding patterns in data. And I also enjoy deepening my understanding of a problem and representing the results as accurately and truthfully as I can, so that you have the most representative conclusion. And in fact, codebar gave me the courage to make that transition from academia to industry. When you work in academia within a university, it's a very focused track into becoming a lecturer and tenureship or working as a lab lead. And so it was very difficult for me to understand what roles were available in industry that I could have skills that were relevant to. So through mentorship from codebar mentors, they gave me the confidence that I could indeed find a role that would fit. So I've been a data scientist for, I guess it's coming up to 3 years. And so what do I really do? What does my day-to-day job look like? I think the first aspect of my job, and it really cannot be understated in any way, is understanding the problem. And understanding the problem myself, but also understanding the problem with the team lead, the senior stakeholder, for example. I was a consultant for a long time. So that means I work with different clients. So it's understanding what the client's problem is and working out what their key performance indicators are. So what are their deliverables, and how my outputs can be measured against those. Is a client or is a senior member trying to predict whether, say, someone falls into a specific group, or whether there's a specific price for an item? Do we need to predict that? So really trying to boil down exactly what they need and how we can get some staged outputs that can be measured. So I want to emphasize this linking to business objectives, because that is something that really did surprise me about the role, is how business centered it is. It really is about thinking about how the company functions and what are their goals and aims. So often they're looking to minimize costs or optimize operations. They're looking for data-driven products. They want competitive advantages. They may want a prediction of the service, what the service will look like if they change something in that service. So really understanding the business and making sure your outputs and what you're doing relates to the business and the business's goals is really important. And I think that's something that I had to learn as I went through as a data scientist on different projects. So as well as understanding the problem, there is also the data collection part, which is, do they have the data they need to answer their problem? Are these data in a machine readable format? That sounds like a funny thing to say, but I've worked with a lot of government clients, and data can come in very different formats and at very different frequencies. So do they have the data they require? Is it in a digestible format where it can be linked, where it can be put into a cloud environment and used by you? So once you've got past the question, the data collection part, there comes the data processing. And a lot of data scientists complain about this, having to look through data and trawl through it. But actually, I think it's a hugely important part of your job to really understand the data you work with. Its frequency, its seasonality. You will obviously want to look at outliers. So data that don't follow a normal pattern, is that something that's expected of the system? Say if there was a yearly service, so that's a service outlier. But understanding where those outliers are coming from is really important. So as part of this data processing, you're cleaning the data. So you're looking for outliers and understanding whether they need to be removed or not. Often they shouldn't be removed. You would transform your data. So maybe you might link data sets that have similar date timestamps. You'll want to filter data maybe if you only want to look at specific subgroups. You don't, sometimes more data is not actually better. You may want to aggregate your data. You may not need the resolution of a femtosecond. You might just want it every day. You, as I mentioned, want to look at missing data because that also affects your model as well and the data that you're putting into your model. And then you also want to convert your data into what's called a design matrix. So we have X data and Y data. So the Y data is what you're trying to predict. Your X data is what you're putting into your model to then try and predict the Y data. So once you've got your data processing finished, and that does take an awfully long time. And again, it really just depends on where the company is as to how long that will take. You then get to do what we all get excited about, which is this bit up here, is the machine learning. Where you will train models, you will evaluate models, and hopefully also productionize models. So you're basically trying to create a procedure that can look at the data, use an algorithm, and be able to predict from that data. And that's what the training of the model is. You'll evaluate your models, you'll see how accurate it is at predicting new data that's fed into the model, and then you'll productionize it if you think this model is accurate enough. And that's again where you come back to the business and decide what metric you can use and how accurate it needs to be. So when you productionize a model, that just simply means making a model available to other systems within your organization or via the web so that it can receive data and return predictions. So I think these are the three main sort of broad tasks that you're faced with as a data scientist. And I think the science part really comes from the understanding of how to define the problem, if I'm honest. I think defining the problem, creating what we would call maybe mini experiments to produce outputs regularly for the senior member or your team is really important. And iterating and evaluating, these are all skills that you learn as a scientist. And that's where I've seen my academic background come really into play in the role. But every data scientist role is unique. And I think if you are thinking of going into data science, it really, really pays to look at the company. It's also why the interview process is painstaking, because it seems as though there seems to be a bespoke process to each company, which will have often 6 rounds. And it almost feels like a full-time job finding a job in data science. But it does pay to really look into the company, speak to the recruiter, and ask questions such as, what is the team comprised of? So do they have roles such as data analysts, data engineers? And the reason I mention this is if there are data engineers within the team, you will do less of the data processing part. If there are data analysts, then you might do less of the data visualization part. If there are business analysts, you won't need to interact as much with the stakeholder. You can also ask the recruiter and also the team themselves, if you can speak to a representative of the team, what kind of questions they're trying to ask. If their questions are very kind of blue sky, then that's interesting, but also that can be very hard to deliver if you are the only data scientist in the team. If there is a huge data science team, then yes, you've got the support and the infrastructure to help you get to that. Talking about infrastructure, you can also ask them a bit about their tech if they're willing to disclose that. So do they have a cloud service available? How do people work together? How do they deploy models if they are deploying models even? So understanding the data maturity of the company, the team, and the questions they're asking can really give you a good insight to the role of the company. And it's really important that you understand that, because a data scientist can vary very much on a spectrum as to what you'll be doing day to day. So the kind of things that you could be doing are obviously coding. So if you love to code, then you'll want to be kind of more leaning towards the modeling engineering side. There's also data visualization. So as I said, I love to visualize data as well and tell stories. So that's more of the data analyst side. So you might want a role that has a bit more of that in its job spec. There's also research roles. So if you really want a very similar role to academia, where you're kind of given space and funding actually to explore ideas and really do those blue sky projects, then having the title research in the job title, would allow you to do more of that. So understanding which aspects of the role that you might want to focus more on, which appeals to you more, would also help. So the common tools that are used, so obviously, I think most people are aware that Python is very commonly used by data scientists, and I definitely use Python all the time. R is a statistical language, so you don't have to be a complete whiz at R. I think it's very important to talk to the recruiter in the company if you're applying and just check what the languages they're using, what they predominantly use. You can always import statistical packages from R using Python, which is commonly what I do. Packages that are useful, so TensorFlow is great if you're creating models, and Keras is a helpful package on top of that. Data visualization packages, I can't stress how useful they are. If you've got good working knowledge with Matplotlib, it will help you with many of the others. But Seed1 is also quite a nice one as well. Scikit-learn is incredibly useful for statistics and also machine learning as well, doing some of the modeling. And a lot of it can be done in scikit-learn. And there are some other statistical packages that I use, like StatsModel as well. So in terms of just a broad overview of machine learning, there are many types of machine learning frameworks actually, and more and more we're seeing hybrid approaches. But if we just think of the three main types of learning models, there is supervised learning, which describes a class of problems and involves using a model to map between input examples and a target variable. So you have labeled data sets basically. So you might have an image that you feed to your model, and then you know that should be a car. So the model should label it a car. So these are supervised because you're involved in predicting a class or a label. So there are two types. There's classification and regression. So classification involves predicting a class label, and regression is when you're predicting a numerical value. Those are the two main ones. Unsupervised, which is often a difficult one, describes a class of problems that involves using a model to describe or extract relationships in a data set. So unlike supervised learning, it operates only with the input data and doesn't have any target variables to predict. So it doesn't have any labels that it can work from. And there are many types of unsupervised learning. Some of the more well-known ones are clustering, where you're finding groups in data, or density estimation, where you're summarizing the distribution of your data. So, and often visualization is a really useful tool when you're working with unsupervised learning. And then the third class of learning models within the machine learning is reinforcement learning. This is where an agent operates in an environment and uses feedback in order to decide its next action. And it's different from supervised learning and unsupervised learning because there's no fixed training data set. You allow the agent to explore its environment, and based on feedback from its current state and also historical information that's cached, they then choose the next action to maximize the goal. So it's about maximizing goals. So the one other really important aspect of being a data scientist is understanding metrics. And metrics are really important because they help you understand how to evaluate whether a model is good or bad. So as a data scientist, you will prepare a data set with features, so for your model to learn. So your data set might have images of a car and your feature, or cars or boats, say, that was the classification. And so within that data set, you might have features that is the bottom of the image blue? If it's yes, then it's more likely to be a boat, basically. Is there a license plate in the image? So these are features of your data set, and they could be binary yes or no answers to them. So it's these features that are going to help your model to learn. But once you've loaded these data, the data into your model, and you have this model, it will then make a prediction, and you can score how accurate the model was in predicting the target labels. So how many of the correct, I've got a really rubbish slide, but I'll show it anyway. So the prediction here, say, of the model is that this image is a car, but it said this one is a boat, and it said this one here is a boat. And you can see the feature 1 here was windows. So these are the different features here. And this is what actually it should be. These are what these actual images are. So you can have an accuracy score after the model has made its predictions for each of these images. You can see it's got 2 out of 3 right. But there are different metrics for different problems. And the reason why it's so important to understand these is because your model, how good your model is based on how on your metric. So you may decide, I will add in another feature that says if there are circles in the image, then it's a car. So if there are circles in the image, then yes or no. By adding that feature, you may improve your metric. So you are then going to assume that your model is better. So the metric is also used as well to improve your model. So if you have an architecture for your model, you might add more layers to your model or more complexity to your model to improve your metric. So it's all based on your metric. So it's really important to understand what metric is the correct metric for your problem and whether you're using the right model with that metric. So I just wanted to emphasize that as an important part of being a data scientist, because not only is it important to know how to improve a model, it's also important to know how to then relay it back to the business, explain to them what you are doing. Like, what does it mean when you say you have a 60% accurate model? What does that look like in terms of, that means it's doing 60% of the images, it's correctly classifying as either a car or a boat. And you may break that down to look at how many of the images that were car were actually correctly classified. So it's really being able to take the high level modeling and mathematics and being able to explain them back to the business, I think, is another important characteristic of being a data scientist. So I think those are the main points I wanted to convey to you. And I think the main thing that struck me about becoming a data scientist is how business focused and orientated it is, and how much client interaction I ended up having to have. So I think understanding that can be a very big part of the role is important if you were expecting a role that is very mathematical and very model based and very statistics based. You can get that if you find the right company and the right people, but I would say, at least having worked on multiple projects as a consultant, it really depends on the maturity of the company, and lots of companies aren't at that stage yet. So I think that was everything I was hoping to say to you today. But if anyone has any questions, please feel free to ask. Thank you.
Hey, thank you so much. And we've had a few questions come in, which is so I'll go through them now. The first one is, I'm having an hour-long trainee data scientist interview tomorrow with a large insurance company. Can you give me any tips? And they said they prepared the talk about company values to demonstrate 2 of their projects. But any tips for the interview?
Yeah, that's a great question. So I guess you probably, I'm sorry if you've already done all of this, but I guess you've looked at the job specification first and just checked what they really saw as what a data scientist is. Because as I said, every data scientist role seems to be unique for each company. So what they define as a data scientist role will be described by that job specification. So if they require you to be able to create visualizations, they expect you to do data cleansing, maybe they'll expect SQL, then you'll know they may not have as much of an engineering support base. But if the job spec is also describing regression and classification, then they're also expecting you, I assume, if it's in the job spec, to be able to cover those aspects too. So it's good to really reread the job spec and know exactly what they're asking of that role. The next thing I would say is read up about the company, which sounds like you have, and try and understand what their aims are, what their goals are as a company, where they're looking to. I always find it's really useful when you're on a company website to look at their graphs or any visuals that they've already got, because that really tells you already kind of what their dashboards are like and what their analytics is already like. So if they've got any kind of graphics that you can see, that's really helpful to give you an insight to where their data maturity is. Other tips for the interview, I think I absolutely hate interview processes. I think they're really scary, but it is so true, and especially with the data scientist role, that it is also an opportunity for you to ask as many questions as you can think of to really understand what they are asking from the role. And if they ask you a question and it happens, and it will happen on a machine learning method or a metric or an algorithm that you are not able to bring up the math for or recall straight away, you can have a go. But if you don't get it, it's fine, because it's such a broad field that it's impossible. I'm telling you, it's impossible to remember every algorithm and every answer to all the 100 data science questions that can come up in an interview. So it doesn't mean that if they were to judge you based on that, then they're not a great company to think that you have to be able to reel off those kind of answers. So that's my advice. So prepare as much as you can, but then when you're in the interview, you just listen and absorb as much as you can, and make sure you take the time to ask your questions.
Thank you. Maria added this, it's their second round of interview, so good luck. Good luck. Yeah, good luck. Okay, the next question is Python enough for data science roles, at least during the interview stage? I've heard C++ is also required.
So I've never had to use, no, that's a lie. I have had to use a little bit, but that was for a government project, and I probably shouldn't have had to use it. But I think, no, I've not had to use it specifically for a data scientist role, and that shouldn't be really required of you. And if it is, then you can ask them if there's an opportunity to learn it from another person. So yeah, see it as an opportunity to learn, but it's definitely not been a requirement from the jobs I've seen.
Perfect. Someone said, how did you prepare to apply for your first job as a data scientist? The skills you had from your research work in academia were enough, or did you end up taking extra courses before applying?
That's a great question. I think I started coding in MATLAB, which some people may know, which is quite common in academia. And then in my last two postdoc roles with two universities, I was using Python. So I was pretty comfortable working in Python with stats and some of the modeling packages. I did do a few courses, but to be honest, I think if you find the right company, if you're coming from academia, if you find the right company that has ex-academics in the team, so people have also made that transition, then I don't think you need to have done the courses. A good course is the Fast AI course. I can send a link on the chat group, which is free, and that's a really useful one for deep learning if you happen to be doing deep learning. But I didn't do any. I did do the Andrew NG Coursera course, but I mean, I don't think it was very helpful. Like, I don't think you would need that in your day-to-day job, to be honest. I think the most important thing is to get your foot in the door and get experience. That's the best way to do it.
Perfect, thank you. Lots of questions on like interviews and beginner, which is, perfect. The next question is, I'm keeping an eye on job boards and honestly finding it disheartening how much experience is required for a junior data scientist. They typically see 2 to 3 years experience is required. Do you have any advice for those who would like to become a data scientist and are considering a career change?
Yeah, I think that is the really tough part. So as much as some of these companies think they need a data scientist, and often you end up spending a lot of time data crunching and doing a bit of data engineering, when you do get to the real modeling and statistics part, it helps to have some experience to know how the data works. But I think if you really can't see, there should be some junior data scientist roles, and where those appear tend to be the bigger companies that have data science teams. I think I showed a slide which had a data science team organization. So if you have a large company, they appreciate that there are junior data scientists, middle and senior data scientists. But if you just want to get into a data team and get more experience, say, in coding or more experience of working in industry, then there are other roles. So there's a data analyst role, which focuses a bit more on the visualization, but includes statistics. There's also, you can apply for a junior data engineer role, which will help with coding. And I think it can never be underestimated. I always want to improve my coding abilities. Having worked in Python for a bit now, I still want to improve and make sure I can write better tests and better code, because mistakes are so easy to make. So looking for junior data engineer roles, junior data analyst roles, if you can't find the junior data scientist role. And then reaching out to data scientists really helps, because they may hear of internships or short projects that you might be able to join on. So I've left my email address on the PowerPoint, but I can put it in this chat. So maybe you can send me an email after, whoever had asked that question, see if we can find opportunities.
Amazing, thank you. Okay, next question. How easy / difficult is it to transfer from a data analyst role into a data scientist role? They have a degree in maths and statistics, but it was 15 years ago.
Yeah, I think it's about getting onto a project where you can show that you've done some data science. So if you can find that project in whichever company you're in, where, and even if it is a bit in your own time and you have to push it slightly, where you can use a model to give insight and help the business, even if it's at a preliminary stage. I think having that as evidence is really useful. So and actually, I honestly think if you're already in the company, it really helps. So you're in a great position right now to just keep your eyes and ears open for a project where you can potentially show more insight to the company through using some machine learning. I'll try and give an example. I was on projects with an organization, and they had a data set that could be used for a supervised learning problem. So basically a senior stakeholder had a problem, I turned it into a supervised learning problem, and I knew there was a data set around that could be used. So I used H2O .automl, which is a package, and I was able to classify these data and give insight to the company based off that. And it was just a little side project that I did. And a lot of it actually was in my own time, but it gave me a little project to present back to the senior stakeholder to make them invest a bit more time into data science. So sometimes that's a great way to do it if you want to transition into data science, is finding that project or opportunity where you are right now.
Perfect, thank you. Next question. This person has completed a data science course on Udemy during lockdown. Any tips on how to choose a project to get their teeth into?
Definitely something you enjoy and love, so data that you like. So I think I mentioned before, I'm really interested in behavior and how we learn, so how we learn from our environment. So I really find that kind of data set interesting. But if, for example, you're interested in climate change, maybe there is a much more free data than you realize out there. So if you can find a clean data set, say of satellite images, but basically something that really appeals to you, and also potentially a domain you're interested in. So I was interested in neural networks, so focus a lot on recurrent neural networks, but you may be interested in computer vision a bit more. So think of firstly the subject area, if it's something that really interests you, and then secondly the kind of data domain. But the reason I say that is because you want to get your teeth into it, and you'll stay up late or wake up early to work on it. So yeah, something that really interests you. That's my best advice for a project.
Perfect. Next question. Is it important to have very good maths skills?
I think the most important thing on the job is the willingness to learn. So you just need to keep wanting to learn. And if this is something that you have, I mean, you have to have an appreciation of maths, but if your math isn't, as fresh as it used to be, that's totally fine. You just need to be willing to learn and putting the time in. I think I've always had to learn. And that's something I actually love about the job. I always want to be learning. So just a willingness to learn.
Nice. Someone said, do you know of any online resources to brush up on presentation skills? Yours are really good.
Thank you. um, any online resource for brushing up? I think practice. So maybe you could read up on a certain aspect of coding or something you're interested in and present at a codebar or even the Codebar conference. It's a really friendly community. I've actually done one of the codebar workshops as well. It's really, everyone's really welcoming. It's a great place to just present and get feedback afterwards. So you can reach out to certain people after the session. If I'm joining, you can reach out to me after and ask for some specific feedback. But codebar is a great place actually to start presenting and practicing your skills.
Yeah, and on the note of that, next week I'm going to be opening up an afternoon where if you've got an idea of the session for the unconference, you can book in a 15-minute session with me and we can just have a chat. And sometimes I know people have ideas, but they just need to like talk to someone and like flesh out that idea. And so yeah, also another link to Global Diversity CFP Day, which is more kind of focused on conference talking, but it is also it's still public speaking. It's still the same skill, and that's a really good event to look at as well. It happened last year. It happened around 20th of February. They will have it again next year. Really good place. They do a mix of talks of people who have gone through the process and they're given advice on public speaking and CFPs, and then you get to like write your own little CFP, and then if you want to practice just pitching your idea you can, and so that's a really good resource as well.
Oh yeah, and one last thing to say on that is also just to remember not to assume too much of your audience. Even if you're speaking to an audience of experts, it's good to just keep explaining even the simplest ideas. I think a professor once told me, and I love this analogy, it's like taking a child's hand and walking them through somewhere. So you're just leading someone through your presentation. I think that's not that I've done that this time around, but that's how you should think when you present. So maybe that's more general advice.
Well, a bit of advice I saw previously, and it kind of stuck with me, is speakers that you have listened to and you've liked, make a note about what it was that you liked about the way they spoke. So for example, with Anushka, it's like actually a very calming voice. Like if that's what it is, like make a note about what it is that you like about the speakers that you admire, and then try to practice that. It's I saw someone give that bit of advice, and then I found it actually incredibly useful. Okay, next question. How often are you using statistic hypothesis testing in projects?
Yeah, that's a good. Not as much as I would like, in honesty. I think I spend a lot of time defining problems and data kind of pre-processing, at least on some of the projects I've been on. But where it has been useful, I have definitely been very clear about what I'm doing. And again, this is the communication aspect. So explaining why you need to show error bars around a mean, what's the importance of variance, what statistical tests are. All of this is, when you get that opportunity, it's almost a responsibility as a data scientist to make sure it's done accurately and it's represented correctly, especially if business decisions are being made off that, where people are spending money or time or resources. So it's not as often as I would like, but when it does occur, I make every effort to make sure it's as accurate as possible.
Someone said, what was the AI course you recommended? I think
last day. I'll put the link in the chat.
Yeah, and I'll make a note of any links added as well, and I'll make sure that they're in the video description on YouTube as well, so people can refer back to them. This person wonders how your work allocate your time among coding, meetings, documentation, reading papers. They wonder about that.
Yeah, I think you need to protect your time as a data scientist, because you will find there's probably a lot of things you could be involved in. You'll have skills where you'll be able to help with some of the data engineering, some of the data analysis, but if there are people that meet those roles and they're not always expected of you, it's important that you protect your time to do what you're supposed to do in your role, and that's something I had to learn the hard way. So for me, also, I do actually really enjoy coding, so as much as possible I'd make sure that a large amount of my day is spent coding, and where meetings need to happen, that they are defined beforehand. So often when we schedule a meeting, there would be objectives for the meeting in the meeting description. It sounds very formal, but it's actually very useful so that you know that those objectives are met within those 45 minutes or half an hour, however long it's meant to be, because your day can easily be taken up into meetings. In terms of documentation, that's a really important aspect of actually just being in industry, is documentation, especially with your code as well. And I think for me personally, it helps to document every day a little bit, just because otherwise the next day I might have forgotten to do something. So I try and just near the end of the day, I don't know what tools you might be using, but on projects a lot of the time we've had Confluence and places like that where you can jot down things that have happened in the day, or even just tests that you've run and screenshots. Little things like that are super helpful for someone else joining the project or someone else picking up your work. And reading papers, I wish I could do that more. I don't do it enough. I think I would read so much when I was in academia, and I don't do it enough now. And I do that terrible thing of picking up on people's threads and only half reading papers. But I have a young daughter and she's starting nursery soon, so maybe I'll have a bit more time to do that.
Okay, next question. I won't take any more questions because 2 more have come in, so we'll take those 2 and then no more. So do you know if companies hiring have mentorship programs to support people in junior roles? Like, is that common?
Not in data science, actually, and I think it should be. I know in other roles, and I think codebar is a great place to try and find those. So in terms of those opportunities, I think reaching out to data scientists themselves. So do reach out to me afterwards and I'll see if I can at least ask colleagues in the fields whether they do offer that. Often it's in-house because you obviously need access to data as well. So if you're within a company and you're in a different role to a data scientist, you could ask to be mentored slightly by a data scientist in that company. Otherwise, reaching out to other people. But I don't often see internships in data science in companies that are paid as well. So if you're looking for a paid internship, that's quite hard to find. But there should be more of that, I think. But yeah, so do reach out to me after this.
Perfect. Next question. How important do you find field-specific knowledge in your modelling? Heard that's more important than data scientific tools.
Oh, I think my role is useless without what we call SME knowledge. So yeah, I think data knowledge is incredibly important, but often I've been working in a company where there are people who are experts in the field, and it's really important to have those because it's very easy to make a very accurate model that's predicting absolute rubbish. So you need somebody who really understands the data set to kind of help hone your analyses. So, but that usually comes within the company. You'll have people who are domain experts, and through looking at data and understanding and reading, I mean, that's the whole science part about it, learning, you will pick up more and more as you go through, but having those people within the company, they're invaluable, but they will be there.
Okay. Oh, we've had 1 more question come in about bootcamp, and then we'll call it a day. But someone has said, coming from a completely different industry, not academia, do you think a data scientist bootcamp is a good way to make a change in career? Have you encountered people in the industry that have learned that way?
I haven't, but that doesn't mean they don't exist. Data science bootcamps are great because they give you good basics and they give you confidence as well. I think it's to the question above as well. I think internship, practical kind of mentorship is the best way in some ways. So getting that small internship, getting projects. A lot of people rate Kaggle. I haven't been a big Kaggle user, but Kaggle is a data science competition you can use where there's open data sets and you can kind of read people's past posts and how they've looked at the data problem themselves. That's a useful tool as well. But so I think bootcamps are great, but I think just experience it's like with everything. I think it's just time and effort, and then you learn and you pick up. I think that's the best way.
Thank you so much for coming and giving this talk today. I know it was one of those topics that people are so interested in, as with all the questions coming in. I think it's demonstrated through that. So thank you so much for coming and giving this talk today. And yeah, thank you so much everyone else for coming.
Thank you so much, Kimberly. Thanks everyone.